Good afternoon. Assalamualaikum. Okay, as mentioned yesterday, today we will do the exercise from the final exam May 2022. Try to proceed this question using Newton-Raphson and secant method. I make it bigger. Is it clear now? Okay, the question asks you to compute the root. Okay, root for the given fx using secant method until 4 iteration. Okay, so this is your stopping criterion, 4 iterations only. Initial guess is this one, xi minus 1 and xi. Okay, secant method. What you need to identify what is the equation to find the xi plus 1. Okay, then proceed with the iteration until 4 iteration. Do it with secant first, then proceed with Newton-Raphson. This question, it doesn't mention, it doesn't ask you to find the EA, right? There's no statement for you to calculate the EA, so you can leave it up. Just do until 4 iteration. You can also include the data of the fxi if it can help you to ease your calculation. Okay, so for the first iteration would be xi minus 1 is 2.5, xi is 3.5. Okay, so you find out your xi plus 1. Then move up to 4 iteration. For the Newton-Raphson, since it requires only 1 point, so you can start with the xi. This one also, if you find it is your calculation, you can just put the column here. For Newton-Raphson, the xi at the fourth iteration, you get somewhere 3.3446. I think most of you. Balkis, correct? 3.3446, right? Okay, so basically it won't deviate too big for both route using different methods. How to know your answer is correct? Yeah. Substitute back into the equation, so it should be approached to 0. Okay, so for that, for those who did not get the correct answer, you can check back your calculation. Okay, I want to share you how I distribute the marks. You can see over here, it is 10 marks. Okay. Okay, this is how I distribute the marks. Since EA is not required, so even though if you calculate your EA, there is no marks allocated. Okay, and the fxi -1, fxi here, if you don't show it in your answer, no worries. I will still consider your marks either in your step or calculation. Okay, but the most important part that I want to see is xi -1, xi +1. These three. Okay, so each mark, each point, each data will contribute half marks. And the correct equation will also contribute the marks. So if at least you are not sure how to answer it, or perhaps you don't have enough time, just write out the formula. Why I give marks even though the formula is provided at the appendix? Because there are a lot of formula, but I won't label it for which method or which method. You should identify which equation for which method. Okay. Any question for this part? Clear? Now, if you haven't done the Newton-Raphson, perhaps you can proceed later on within your own time. Now, I want to proceed to chapter 3. Okay, before that, I just conclude chapter 2. So as conclusion for chapter 2, we had done for open method. Okay, open method, which is no lower and upper range. Okay, you either will be given one starting point. Newton-Raphson will be one starting point. Whereby the second method is two starting point. But these two starting point is not the range. Okay, it's just for you, for guiding you to find the new XR. Okay, the new value of the X. So in bracket method last time, we have 3, graphical, bisection, and false position. All you will have XL, XU. Okay, whereby for open method, we have 3, fixed iteration, where you will need to rearrange the equation and validate the equation. Whether it is correct to be used for the iteration part. Whether it is not a bug. Okay, whether it is converging to the XR. Okay, then Newton-Raphson, where the assumption is based on the slope, the slope that will direct to the new point. Okay, Newton-Raphson, where it used the analytical differentiation. Okay, for Newton-Raphson, whereby secant method, it modified the differentiation part over there, where it used delta x over delta y from the slope given. Okay, any question for chapter 2B, open method? Come again? Round off error and no, two different things. Round off error is the error that you need to find when you round off the figure. For example, the pi value, if you press the calculator, you will get a long version of the value. But in standard, usually in calculation, you will only use 3.5142. So the round off here, you'll have some error. Okay, either you are using perhaps 10 significant figures with 4 significant figures. You round off to 4 significant figures. So there will be some round off error. Okay. Okay, any more question? Clear? The main target is to find the root XR. Okay, main target is always to find the root when y equals to 0. Okay. Okay, so now I move to this one, nothing. I move to chapter 3, which is the Gauss elimination. The Gauss elimination is matrix form. Chapter 2, nonlinear, bracket and open. But chapter 3, it is a linear equation where x power 1 only. Okay, and we convert the equation into matrix. Okay, convert into augmented matrix. Okay. The aim is to find the unknowns, x1, x2, and x3. Okay, these equations, these three equations, it will result in 3 by 3 matrix. Okay, you can have 2 by 2 matrix or 4 by 4 matrix. The method for Gauss elimination is the same, regardless how is the matrix, 2 by 2, 3 by 3, or 4 by 4. Okay, but usually the question will ask related to 3 by 3 matrix. Okay. Now I will just introduce you the slide first. Later we will do the exercise so that you can understand further. Gauss elimination consists of 2 steps where you will need to do the forward elimination. Okay, forward elimination of the unknowns. You have x1, x2, x3. So in your matrix, you will need to do the steps in order to zero all these unknowns. Okay, so this way, the equations are reduced to one equation and one unknown in each equation. What does it mean is, let's say you have For example, this matrix. So you will need to zero this part. Eliminate one by one. So it will be the value over here. This part will be 0. This part you will have numbers. Okay. What it means by this is the equation are reduced to one equation and one unknown. Here, you will only have one value over here. So here you will be your unknown, referring to x3. So here perhaps your value. You have your value over here. Okay, so for the third equation over here, since the rest has been zeroed, so here you have number. Here also you will have number. Okay, for example, let's say this one left with 5, x3, then here 10. Okay, so from here, using the third equation with only one unknown, you can calculate to find out what is your x3. So x3 over here will be 2. Okay, that's the purpose using Gauss elimination. It eliminates one by one so that it reduces to one equation and one unknown. Back substitution over here is once you have the value for x1, x2, and x3, you will substitute back to the original equation so that you know your value of the x's are the correct value. Okay, later we'll do exercise, then you can understand. I'll explain you the concept first. Okay, in Gauss elimination matrix, you will find the term pivot. Pivot means we lock that row. Okay, for example, just now, you have here row 1, row 2, and row 3. In order to zero this, you will need to pivot first row. You will use this as the basis. Okay? Because you will need to divide. Okay, divide the first equation by A11. A11 here is the first row just now. Okay, so here is the row. This one is column. Number of row, row 1, column 1. So this is the value. Row 2, column 1. This is the value. Okay, and row 3, column 1. That is the value. Okay, this is how they label for the matrix. Okay, in order to zero this part, you will need a factor. Okay, how to zero this part? Let's say this is the original equation. The original matrix. Okay, matrix. Now here it's 0 over here. A21. It needs a factor because you are using the same factor to calculate for this row. Okay. Now you listen first lah. Just capture the term, the factor. Okay. So each row will have their own factor in order to zeros the thing. Okay. Now, okay, straight away to the example so that you understand further. Just copy this one first. Later we proceed step by step. Okay, so now we have three equations, x1, x2, x3. It asks you to find x1, x2, x3. This is a straightforward question. It directly gives you the equations. There are certain questions where you need to generate to develop this equation from a given case study. You know, to answer it, we know that Gauss elimination, the question here, find x1, x2, x3 using Gauss elimination. Okay, we know that Gauss elimination, the target is to zero the bottom triangle. Okay, this part should be 0. Okay, now first step, you need to convert the equation given into matrix form. So here x1 will be in column 1. Okay. So arrange it accordingly. -3, 5. I think you have learned this in statistics. Max 1. You have taken, right? So you know already. Gauss elimination. Who's teaching last time? Huh? Come again? Nur Fazila. Okay, so you already know lah the pivoting thing. Okay. Now this one, the matrix over here, the first matrix is 3 by 3. The answer over here is, what is the dimension of this matrix? Huh? 3 by 1. Row, 3 rows by 1 column. Okay, 3 by 1. Now, next step, what you should do? Huh? 0, 8. Okay. Now, I always ask my student to form into augmented matrix first. What augmented matrix means, you combine together the 3 by 3 and 3 by 1. Just extra step to make it easier to see. Okay. Okay, so next step, 0, 0 the bottom triangle. Okay, this part is a bit tricky because you need to find the factor on what, which row, which column to use. Okay. All of you had done Gauss elimination. So I don't need to go so details. Okay, I just need to refresh back. Okay, first we pivot the first row. Then this is R1, R2, R3. Okay, now you need to zero this part, the -3. So we pivot the first row. Okay, pivot over here. So the new equation to find the R2, R prime 2. Okay, let's say first row, first column. What you should use? Huh? +3. Wait, did I get the question wrong? Why +3? Mm-hmm. Yes, correct. Now, how to get that +3? How to get that +3 to make it 0? Yes, you can get 0. This is the correct way, +3. But to get that +3, we cannot simply use just +3. Okay, we must find the factor because you will need to use the factor to calculate the new value for R22 and R23 as well, R24 as well. Okay. Five or 3. Okay, here's how it looks like. 3. Okay. This prime means new. No primes means the old, the original one. Okay, so R2, the original value, minus R21, over, we are pivoting the first row. Okay, so R11 multiply by R11. Yeah, see how it will get 0. Now R2 here is -3 minus R21 is, here is R21. So R21 -3 over R11 is 20. Multiply by R11, which is 20 as well. Okay. Cancel out, then here you will get 0. Okay. What? R3, you mean over here, the R11. Okay, now we need to use the R11 because we has pivoted the R1. R1 is being used as our base. That's the function to pivot the R1. Okay, we base on the R1. We base on the row that we pivot. Okay. Now, what I meant by the factor is this one. This is the factor that you will be using to find R22, R prime 22, and R prime 23. Okay, try to calculate the R prime 22 now using the whole number of R22, which is this one, -2249. Okay, minus the factor. This is the factor that we will use for the whole row. Okay, so this is the factor, same factor. Then multiply by R12, because we are focusing on column 2, row 2, column 2. So here it will be 15. Now what you get for that? -149. Naresh, what you get? Then calculate. Alif, what you get? The new R22. This one. Aisha? Right. 0.001. That is the correct answer. Okay, try to find the R prime 23. R prime 23. So 7 minus the factor multiply by 10. What you get for the R prime 2, 3? Correct. 8.5. Wait, I copy to the next slide for the next calculation. Now, this matrix will turn into the new matrix. Pivot row 1, so row 1 will remain. Wait. What is it? Correct. Yes. You should change this as well. 1.750. 51. Try to calculate what you get. Okay, so just now you have zeroed this part. This one is 0.01, 8.5. This one roughly you will get 8.501. Okay, so now we want to zero this part and this part. Okay, first we zeros this part. Still pivoting the first row. Because we want to eliminate x1. Remember just now? It eliminate one unknown per time. So first column referring to x1. So that's why we pivot row 1. Okay, so now to eliminate x1 in row 3, number 5 over here. Okay, still pivoting row 1. Okay, the new R prime 3, 1. 5. Okay, the original 5 minus 5 over 20. Multiply by 20. So you get 0. Okay, this is the factor that you need in order for you to calculate the rest of R prime 3, 2 and 3, 3 and also 3, 4. Okay, so let's write R prime 3, 2. The original value, which is 1, minus by the factor multiply by which part? 15. What you get? Okay. Correct. Minus 2.75. Negative 2.75. Okay, here you'll get negative 2.75. This one you should get 0.5. Then this one is negative 2.25. Okay, this is not finished yet. We have zeros this part and this part. Now we need to zeros this part. X2. Okay, so to zeros the x2 over here, negative 2.75, we must pivot row 2 because we want to eliminate x2, so we pivot row 2. Okay, next. Row prime 2, just now because this one is after we have zeroed the thing, you will have r prime 1, r prime 2, r prime 3. Okay, so now we pivot r prime 2. R prime 2 remain as it is because we are pivoting it is. Okay. Now this one, the 0 part remains 0. Now we want to find the new R double prime 3. Okay. So now we are focusing on the last row. R double prime 3, 2. 3, 1 no need already because it already zeroed. Okay, using similar approach, the previous value, which is negative 2.75 minus the factor. So what is the factor over here? Minus 2.75 over 0.01. This one is 0.01. Okay, then multiply by 0.001. That's how you get the zero. So for R double prime 3, 3 using the same factor. Previous value minus the factor multiply by R prime 2, 2, 8.5. The row that we pivot. Okay, so here you get a big number. What you get? 23, 27. 23. Correct. 23375.5. Calculate for the R34 here. Same, right? Okay, so here you get the same value. Okay, now we have achieved our target to zero the bottom triangle. Finish the forward elimination part, the first step. Now, second step is the back substitution just now. What does it mean by back substitution is you have the matrix ready now. Okay, so you substitute back to the equation. Okay, we know that this part is equivalent to x3. Okay, so 23375.5 x3 equals to this one. So x3, what you get? 1. Okay, then using this x3 value, refer back, use these infos to find your x2. Okay, here x1 is 0. You only have x2, x3. Okay, 0.001. 01 x2 plus 8.5 x3 equals to, okay, x3, you get 1 just now. From here, you can get your x2. x2, 1 as well, correct. Try to find your x1. I believe it will be 1 as well. Right. How do you want to know your answer is correct? Substitute back into which equation? The original equation. The original from the question. Okay, which is The original equation means, where is it? Here, this equation. So you replace back the findings into any of this equation, sorry. Whether you can get equals, let's say you put the x1, x2, x3 to this equation. You should get 9, your answer. Okay, means check back with the equation given. There's one more thing to check. There is one more method to validate your answer using calculator. Are you familiar using calculator with the matrix? No. Yes. Yes. Miss Fazilah taught you. Is it? No. How do you know, Ale? In which class teach you? Last statistic. Last maths one. Okay. Okay, so let me share with you how to use the calculator. We will use this equation, this matrix. To set up in the calculator. I'm using this version of calculator. Okay, so now first thing you need to click the mode until you find matrix. Okay, so press 2. It will appear mat up there. Okay. Then to set up the matrix, Shift 4. Okay, Shift 4. Now here you need, because we are creating the infos, the matrix first. So we need to press 1 for the dimension to set up the input. Okay, dimension. So press 1. First matrix, let's say we label as A. Just press 1. A. Okay, so A over here. Sorry. Okay, A over here is this matrix. Now, what is the dimension of matrix A? 3 by 3. Okay, so M is 3 equal. N is 3 equal. Okay. Now, it will appear this max A11, meaning that the value that is in row 1, column 1, which is the 20. So, input 20. 20 equal. Then it asks you for the following value. A12. Which one A12? 15. Okay, don't get it wrong to put -3. Row, column. Okay, 1, 2 is 15. Then the rest. Okay, after you have input the row 1, it will appear A21. So you input all the infos over there until A33. Let me know if I go too fast. Okay, once you enter all the values, it will come back to A11. If you want to check, just check all the values. Okay, now we are settled with matrix A. Now we set for matrix B. Shift 4 again. Then press 1. Press 2 because we want to set for matrix B. Okay, which one is your matrix B? X. Huh? Not the X. No. Yes, not the unknown, the numbers. Okay, this is your B. Okay, what is the dimension of the B? Huh? Correct. 3 by 1. Okay, press 3. Enter 1. Equal. Then input your data. 45. Then the next one. Then 9. Okay. Okay, now how to find the x1, x2, and x3? Shift 4. Press number 3. Map. Okay, the one that right up map. Press 3. Just now matrix A is number 1. So press 1. Now A is this side. We want to find the unknown over here, x. Meaning that the A we need to bring to the other side, right? It will be A inverse. Correct. The A here will be will change into divide. B will be, when you bring A to this side, it will be B over A, correct? So this A is equivalent to inverse. Then only we can find the x's. Now, how to do it? Mat A just now. Inverse. This one. Inverse. This one, inverse. Okay, then multiply. Shift 4. 3. Matrix B. Because we want to multiply it with matrix B. Plus, press 2. Okay, it will come out like this. Then equal. So you will get maths answer 1, 1, meaning row 1, column 1, x1. Then press here to check the following. 2, 1, 3, 1. Press here to check x2 and x3. All you get 1. x1, x2, x3 equals to 1. Correct. So your calculation just now is correct. Validated. Okay. Now I want you to try to use your calculator to find out the unknowns of this metric. Wait, let me share. Okay, try to press your calculator. What you get for y1, y2, and y3. For other model, I'm not familiar. So perhaps you can press the function option there. I get for Y1, Y2, Y3. Wait, ah. What is it? Okay, so Y1, you should get what? Y1 just now? One? Only one? Why I get different? Sorry, Y1 you get 1. My answer I get 1.7938. Y2? Huh? -3. Why I get -3.5773? Y3? 2. Okay, just try to check whether you get either of these answers. Okay, this one using calculator. So next week, we will proceed using the Gauss elimination. Okay? Okay, so we are on time. Next week, Monday, we'll continue with the Gauss elimination again. Okay, that's all. Thank you.